requisite audio and video check to make certain people can hear my voice and see the screen, and find the question box on your control panel so you can ask me questions as we go through today's webinar. So for those of you that can find that question box, send me over a message letting me know that you're able to see and hear, and we will be underway to start as soon as I get some responses back. And sometimes there's a subtle delay from when people type the comments into the question box till I see them, but I see Paul now who said can see and hear. Thank you very much, Paul. And generally when I get one person who responds, everybody else is able to see and hear. For those of you that do have questions, I'm very observant of the question box in the control panel, so I'll do my best to answer any questions you have as we go through the material as quickly as after you ask the question as possible. So with that said, it looks like we are now at 10:30. Good morning, everybody. My name is Jeff Spies, and for the next hour we will be reviewing solar roofing best practices for asphalt shingle roofs and discussing the codes and standards and past problems that we've seen, as well as the different products we have available to mount PV systems to an asphalt shingle roof, remain code compliant, reliable, waterproof penetrations for the life of the PV system. The topics that we will be reviewing include the benefits of quality waterproofing, some of the common problems, again a quick review of code standards, best practices. However, this afternoon at 1 p.m., I think it's at 1 p.m., I believe we will be conducting our Roofing Codes and Standards webinar, which is a 90-minute training program that goes into greater depth as to what the codes and standards require. We'll give a cursory overview today of the codes and standards requirements when you're attaching a PV system to the roof, but for those that have an interest, we will go into more depth this afternoon in our codes and standards training. Really, the focus of today's discussion is going to be more oriented towards the installation and waterproofing of the standard roof attachments we have for asphalt shingle roofs. And Quick Mount PV offers a broad range of roof attachments for PV system installation on just about every roof type, with the exception of metal panel roofs like standing seam or corrugated metal roofs. We typically refer customers to our good friends at S5 in Colorado whenever they're looking for a metal panel roof attachment. Otherwise, if it's an asphalt shingle roof, a tile, shake, slate, metal shingle roof, even low slope roofs, we have roof attachments available and flashings for all of those products, as well as some specialty products like conduit mounts and penetration flashings. Our number one selling product is the E-mount that you see on screen. It is of course, our biggest asphalt shingle product, but our biggest product in general. And one of the things that was a new product just about 3 years ago, the innovation is that we developed that special thick black rubber washer that you see pointed out in the right-hand image. And what's clever about that design is it's got a stainless steel washer embedded in that big chunk of rubber, so as you secure your L-foot with your lag screw into the rafter, the downward pressure on that big thick rubber seal actually expands the diameter of that rubber seal, totally filling the cavity within the Q block, that rectangular block, creating a robust, reliable 30-plus year life for that particular seal assembly. We have products for tile, including our new tile replacement mount, which has been a very successful product since we introduced it just a few months back. We also have conduit penetrations and tile conduit mounts for tile. And our quick rack rail-free system for asphalt shingle roofs has been available for a couple years now. We actually have full training webinars specifically on this product you can access at our website for those that have the desire to learn more about that product. For any of our products, you can get a free sample simply by clicking the green button that's typically pictured on the product page, and that's a great way to get the actual product in your hands. You can evaluate it, no substitute for that, and it works as a great sample when you're talking to the prospective customer to show them how you'll make the attachment to the roof and how you'll waterproof for the life of the system. My name is Jeff Spies. I am the Senior Director of Policy for Quick Mount PV. I serve in a number of capacities with industry organizations including NABCEP, where I'm the secretary. NABCEP's the industry certification organization. I'm on the board of the California Solar Energy Industry Association, where I chair the Committee on Codes and Standards. I serve on the UL 2703 Standard Technical Panel, where I lead the task group on bonding and grounding. My degree is in mechanical engineering, and for 30 years I've been training folks such as yourself in a broad range of technical, electrical, and mechanical systems. I really have a strong background in training, where I've organized a lot of technical training conferences, and I do a lot of writing for trade publications and speaking at industry events. But at heart, I'm a solar technology geek. My own home was featured in an issue a couple years back of Solar Pro magazine because we had done some creative things both from an inverter and a roof perspective. And probably what I'm most excited about is over the past year and a half I've been helping produce a documentary film about how the industry started, where we've interviewed 50 plus of the pioneers of the PV industry, including Richard Perez, founder of Home Power magazine, who sadly passed away at his home in Oregon just a few months back. But we take a look at the early days of the PV industry and the space program, progressed to the home power entrepreneurs like David Katz, who helped bring this technology from outer space down into people's homes, and we've got a whole host of the who's who of who invented the PV industry from the late 70s through the early 2000s, where this technology became established in the grid tie market. For those participating today, you will get NABCEP credit. You do need to participate for the full hour, so if you tune in a few minutes late, don't worry, I tend to stick around after the webinar is over to answer any remaining questions, and if you stick around for the Q&A period, you can get the minimum 60 minutes necessary to get one NABCEP credit, which will be emailed to you in 1 to 2 weeks. A lot of people ask right after, where's my NABCEP credit? Well, if you're listening and paying attention, you will hear right now that you will get it within 1 to 2 weeks. If you're not listening and paying attention, I'll repeat this at the end, then you'll likely send an email to Rebecca saying, where's my credit? So I certainly appreciate people that listen and pay attention. It will be sent to you in an email with the PDF link download, as well as download or links to be able to review or view previously recorded webinars. And we are recording today's webinar, so if you in a week were curious to listen again to something I might have gone over a bit quick, you can tune in after you get the email and see that webinar. We do send, a survey pops up after you log out of the webinar. We certainly appreciate the ratings as well as the comments. We continually strive to make these educational events even more valuable for our customers. So I will give a cursory commentary on codes and standards, recognizing that I will be doing a more in-depth webinar this afternoon on the code standards, certification and permitting of PV systems. But one of the things that we like to impress upon anybody new in the industry, or really anybody in the industry, is the multiple organizations that have some say as to what constitutes proper installation of a PV system on a roof. And the wheel of accountability is a chart that we developed years ago. It's changed over the years to try to encompass all of those entities that have some say as to how solar gets installed on your roof. And you can see at the center is the authority having jurisdiction, your local building department, who has the ability to establish unique rules and requirements for a local area based upon unique geological, seismological, topographical, or well, I guess those are the key areas, issues that come up in a particular area. So you can see the jurisdiction establishing more stringent rules than these other entities outlined in this table establish. But in our training this afternoon, we'll differentiate from codes, which are legally required, to standards, which are voluntary guidelines, often tested for listing and required by codes, versus best practices, which are the most stringent guidelines that any solar installer should aspire to. It's not good enough to just have a code compliant system. Code compliant systems are installed day in, day out that produce very little energy. What I want to see is something that's going to work for many years that's also safe and meets the code requirements. So we'll talk about that later, and we'll also address UL 2703 standard for rack mounted PV systems for bonding, grounding, mechanical loading, and fire classification. But now what I'd like to do is get into what we have seen over the years as common problems. And solar has grown tremendously in recent years. I had the privilege of starting my PV career working with the pioneers of the industry, and as a result, I've gotten some very good historical perspectives. And we have seen over the years the waterproofing of roof attachments evolve considerably. And this is an image we like to show in part because it appeared on the cover of a prominent photovoltaic publication about 8 years ago. And you can clearly see that the installers are not using fall protection, which is a violation of OSHA worker safety requirements. Penetrations in this application are not staggered on the trusses, which, while not code required, is certainly desirable from the standpoint of minimizing the number of screws that you put into a single truss or rafter. You can see that on the end, there's no substitute. You have to secure the end of each rail down. That's understandable. But in the inboard locations, it's better to stagger those penetrations. More importantly, we see no visible flashing on these screws in these roof attachments, which means that it wouldn't meet the code requirements and it would void the roofing warranty. And in the early days of solar, standard practice was to put your screw through the roof with sealant as the only barrier to leaks. Unfortunately, experience has shown that this is not a very reliable method. In this example, despite the generous amount of roofing mastic around the perimeter of this roof attachment, you can see evidence in the right-hand image of moisture that's gotten past the sealant, and it's difficult to use sealant on a granulated surface because granulated surfaces are not the most reliable sealing surface. And you could theoretically try to scrape all the granules off from the sealed surface, but those sealant-only solutions have shown themselves to be reliable for somewhere between 5 to 10 years. You can't rely on them for anything longer. In this example, after only a short year and a half in the field, this system, which relied solely on sealant, started to leak. Now, the leak was so severe that it started to rot the sheathing right where that red arrow is pointing. You can see that dark stain, in essence, depicts the point at which the sheathing is rotting underneath those shingles. And the roofer, in a or I should say the solar installer, in a feeble attempt to try to stop this leak, decided to peel the shingle back and put a bunch of sealant. You can see that light-colored sealant just to the left of the red arrow there in the right-hand image. That sealant was ineffective at stopping this water from being able to get through the leak because sealant alone is just an unreliable method of waterproofing. You can add more sealant, as you see in these images. It doesn't necessarily buy you any added protection. It just costs you more in sealant. So realistically, sealant-only solutions are a 5 to 10 year solution at best. Here's an example of an installer who made the mistake of taking a current-carrying conductor through the roof without protection. It should be in conduit. Equally worrisome is that they failed to use proper flashing to make the transition. And you can see that while they put sealant around the point where the pipes and wires enter the roof, there can still be some small areas where water can leak in, and that's exactly what's happened in this example. Some of the flashings that traditionally have been used on pipes could be problematic. We don't see those being used much in solar, but this just gives an example of where a conventional pipe jack that often is used for a vent pipe can be installed incorrectly. In the left, you have an inverted boot. In the right, the shingles weren't cut properly, so they're not laying down, which would become a wind uplift problem in a windstorm. Here we've got a problem where they've nailed the face of the flashing, which you can see the galvanized steel nails starting to rust and cause the flashing to corrode. That face nailing is never a desirable approach. The National Roofing Contractors Association thoroughly dismisses exposed metal fasteners, and putting a nail on the downhill side of a flashing is the definition of an exposed metal fastener. The reason that installers sometimes are prompted, or roofers are prompted, to do this face nailing is sometimes the flashings lift up in a windstorm. Well, that doesn't happen with our solar flashings anyway, thankfully, because of the design of them. But even when you've got a flashing configuration for a pipe like this, there are much preferred methods to preventing flashing lift up in a windstorm than face nailing. Unacceptable, undesirable, and what they did to enhance the ability of the flashing to not lift up in a windstorm is they used count them, two pipe clamps right where that red arrow now is pointing, and they've depressed the rubber seal down into the flashing, creating a water capture area that will accelerate the degradation of that rubber seal. So this is undesirable. Oops, I'm sorry. In the right-hand image, they've simply laid the flashing over the pipe, over the shingles, and plastered sealant down around it. That's an ineffective seal over the life of the system. Flashings on shingles need to be interwoven into the courses of shingles in order to work with the natural water shedding capability of a shingle type roof. In this example, we do have a metal flashing being used. However, they've installed it in the wrong course or the wrong layer of shingles. For this to have been installed properly, it needs to be removed from its current position and put underneath the layer of shingles that it's currently sitting on top of. So it needs to go one layer of shingles closer to the roof in order to be properly installed. And that's painfully evident when you look at the upper edge of the flashing falls about 2 inches short of the headlap of the third course of shingles. That red arrow is pointing right to the area in question, which again the solar installer, in a feeble attempt to stop the leak, put some sealant at that area. It's just not sufficient. You need to come and put this flashing one layer of shingles closer to the roof, underneath the shingle it's currently on top of, in order for it to perform its waterproofing function capably, and to make sure that that upper edge of the flashing gets up into the third course of shingles to work with the waterproofing of the roof. We have seen the growth in recent years of a lot of deck level seals, as we call them, where oftentimes you have a flashing with a rubber seal sandwiched between the L-foot and the roof, and while that is certainly preferred to sealant only, it still puts the seal surface at the water line, which can be problematic, particularly in freeze-thaw zones. We have a whole video on our website that shows when a leak occurs how the damage starts to happen, and you can see the rot that's demonstrated there and also the visible stain. The rot, of course, will weaken the fastener's connection to the roof to the point where, with some older PV systems, I'm aware of installers that have been doing inspections on older systems and literally could remove the lag screw with their fingers because the wood had rotted out due to a slow seeping leak that sometimes doesn't get noticed by the homeowner until very late in the game. Our products rely on elevated water seals where we raise the vulnerable water intrusion point 0.7 inches or more off the roof surface to make certain that the rubber seal lives as dry a life as possible and therefore will last longer than rubber seals that are at the water line. If you miss the rafter, you increase the potential for a leak. Now, I'll point out the fact that typically leaks are visually evident when you do an attic inspection. Not a fun process in a hot day in Arizona. I live in the Phoenix area and I've been in my attic a lot in July and August. I don't like it, but I would do it to make certain that there's no pre-existing leaks before the solar installation. If you do have a leak, it's typically evidenced by the kind of telltale leak stains in the rafters, on the sheathing, and unfortunately, if you miss the rafter, as you can see here, which is a code violation, it will also increase the potential of a leak because as the PV system expands and contracts, you end up with the fastener can walk back and forth. Leaks can get so bad that they start to rot the rafters. What you're seeing in both images is wood rot, and that's evidenced by the color shift of the wood from that orangey color down to a what is a more of a tan or whitish color when the rot's going full bore. Here's an example of a leak due to a solar installation where it wasn't properly waterproofed, and you can see over the years the rot that occurred to the sheathing. I had a bit of this on my roof from a flashing leak, not related to solar thankfully, but a window to roof flashing that had a leak in the nail, and the rot over time. This is exactly what it looks like. Drywall damage tends to start at $500 and go up quickly to the thousands. Mold damage starts in the thousands and can go into the tens of thousands of dollars to functionally remediate. So the actual secondary cost of the leak, you might have to fix the roof, but fixing the drywall, removing mold, can often be more expensive than fixing the leak in the roof. So the building code, I'll again be addressing this in more detail this afternoon, But the building code establishes flashing requirements because they found that sealant-only solutions, like you see here, are vulnerable after a few years after the inevitable cracks in the sealant develop. That's natural. Now, sealant is an excellent supplementary waterproofing measure that's used in conjunction with metal flashing, but by itself it's vulnerable because of its tendency to crack over time. When working in conjunction with metal flashing, that eventual wear of the sealant still provides reliable sealing, but when used as the only barrier, it's an unreliable approach. Flashing, of course, will protect the penetration, divert water from the penetration, and provide you with that side lap dimension, that space, if you will, between the edge of the flashing. I'm sorry, I jumped ahead mistakenly. Let me go to my pen here. So you can see now, the water has to get all this way over to get to the penetration, and on most of our products that's going to be more than 4 inches. 4 inches of side lap protection to prevent that water from being able to access the penetration. All right. Does a lag screw require flashing? Well, in the opinion of the National Roofing Contractor Association, all penetrations require flashing, and if it passes through the roof, as described by the executive director of the Roofing Integrated Solar Energy Certification Program, essentially the roofing certification program for solar installation from the NRCA, John Shale, states, if you've got a screw and it passes through the roof, it requires a flashing. And the International Building and Residential Code have language where they call out that all penetrations must be flashed, but more importantly, they specify that you must flash those penetrations to the approved manufacturer installation instructions from the shingle manufacturer's printed instructions. Similar language in the International Residential Code, which specifically calls out the asphalt shingle manufacturer printed instructions must be followed. Now, the shingle manufacturers, all of the major shingle manufacturers, GAF, CertainTeed, Malarkey, Pabco, Tanco, IKO, Owens Corning, they've approved quick mount PV's flashing, and these shingle manufacturers have specifications such as metal flashing for all penetrations. 4 inches of side lap is specified by some. Flashing up into the third course is specified by all. But effectively, they follow the National Roofing Contractor Association's guidelines, which are pictured in the lower right image here, which have the requirements that the flashing be made of one of the metals that is shown on screen, and important that that upper edge of the flashing get into the third course of shingles, which I'll show in a moment. But I do want to point out that while galvanized steel is a permissible metal, it may not be suitable for certain climates. In this photo, what we are seeing is galvanized flashing in Florida after 4 years, and you'll notice there's a pretty big hole that's already corroded through, and the flashings pictured on the left were the ones that were the least corroded in the system that had been installed only for 4 years. So while there are several metals that are permissible by the NRCA guidelines, as you can see in the slide on screen now, and that includes galvanized steel, galvalume, stainless steel, copper-coated stainless steel, aluminum, lead-coated copper, and lead. Those are the permissible metals, and you can see the different weights or thicknesses or gauges that would be required. In the case of aluminum, you have to have minimum 32 thousandths inch aluminum. But galvanized, even though it's permissible, may not be appropriate for Florida, might work perfectly well in a climate like where I live in Arizona. The NRCA also requires, wherever possible, that you integrate the flashing into the underlayment, but has recently revised that language to accept any manufacturer that doesn't mandate that requirement. Fortunately, all of them allow you to integrate it into an existing shingle roof without having to cut it up into the underlayment. But one of the requirements that's unanimous for all shingle manufacturers is the position of that metal flashing. The upper edge must, I repeat, must be above the nail line, as is shown in the center configuration in the middle and in the right-hand configuration. Both are permissible by the shingle manufacturer's installation instructions, by the NRCA guidelines. The upper edge of the flashing extends above the nail line, and you'll see the left-hand position is unacceptable for 2 reasons. Number one, The upper edge of the flashing is not into the third course as is specified by the NRCA requirements. And when that happens, and wherever that flashing might correlate to a section of shingles meeting each other, that happens usually every 36 inches, then you're going to have the free ability for that water to run down into the keyway where that red arrow on the left is pointing and get to your penetration. Additionally, when you do not install the upper edge of the flashing up into the third course often, you have the bottom edge overhanging the first course of shingles. Absolutely undesirable. And the reason is, in a wet climate like the Pacific Northwest, Northern California, the Northeast, the Midwest, virtually everywhere except for Southern California and Arizona and Nevada and New Mexico, all these other areas, mold can grow in that overhanging edge. So the desirable position, the appropriate position, the correct position, is the two positions shown either in the center or the right. In order to install the flashing a little further uphill, as you see in the right-hand position, you have to cut some shingles out of the way of the mounting block. Perfectly acceptable. You don't have to cut that semicircle as is shown in this diagram. You could just cut the shingle so that you have a ½ inch gap between the block, which is kind of rotated at a 45-degree angle. So that's that configuration is fine. You could also just kind of cut a straight edge cut so that it just conforms to the position of that rectangular mounting block that we have here in the image. To install the flashing up into the nail line, you have to remove the nails. We show that process with a tutorial, a video tutorial on our website in a roofing bar. It's an easy process that is compliant with the code, which requires that you only have 4 nails holding each strip of shingles. They start out with 8 nails, so you might remove 1. On rare occasion, you might remove 2, but that still gives you plenty of nails to meet the code requirements. So I will cover that more in today's this afternoon's webinar on codes and standards, but this is the standard strip shingle held in by 8 nails, and you might remove 1, possibly 2 nails in a single strip. GAF does reference this procedure in their installation process, where they reference if you remove any nails that you then would fill the hole in with sealant, which is a very, how shall I say, conservative approach. So with that, we are now about to jump into the nuts and bolts of selecting products and installing them. And our asphalt shingle roof products is what we launched the company with in 2006 when we came out with the classic comp mount. And the photo that you see up there was taken in those early days before we started staggering penetrations on the roof on the rafters. But you can see a nice home that's overlooking the San Francisco Bay Area right there. And we've got 2 basic types of roof attachments for asphalt shingle roofs: the Q block type with the rectangular mounting block, and the Q base type that uses a separate post and base with a flashing that goes over the top and a rubber seal. The Q block products pictured on the left are really my favorite for so many reasons. Whether it be a new roof or a retrofit, the robust seal design of our Q block product is my hands-on favorite for long-term robust sealing life, cost of installation. The Q base product on the right has some unique advantages to the Q block product. The number one advantage is that it really facilitates re-roof or new roof, where the solar installer can literally have the roof with just underlayment installed, go on and install each and every base precisely on the rafter and the location that you want them to be, and then the roofer can come back and install the shingles and the flashings as they shingle up the roof. That's a tremendous benefit on a newer re-roof, where the solar installer is coordinating his work with the roofer, and it gives roofers confidence that the waterproofing of each and every penetration will be done in a manner that he's comfortable with as a contractor, he or she, and then they would be able to warrant the installation, since the roofer would perform the flashing of the product. So it's a great approach, and that's really its primary advantage over the Q block product. There's a checklist we have here for solar installers. Obviously, you want to, whenever possible, find out the original roofer of record, what shingles you're using, what the slope of the roof is, What kind of warranties might be in place? Is it product warranty only? Do you have a contractor warranty for the reliable waterproofing of the roof? Is there a workmanship warranty? Might the manufacturer back the whole warranty? Occasionally that happens. Obviously, assessing how long the shingles have been on and how much life they have left is a subjective determination in many cases, and one that is necessary to make because there's tremendous cost to having to re-roof after a solar installation. A lot of folks are surprised when they first learn that it costs more to remove and reinstall a PV array, just that labor, so the roofer can fix a leak or replace the roof, than it does to replace your inverter. And almost everybody budgets for the replacement of the inverter. Few folks budget for the cost implications of removing and reinstalling a PV system, which can get quite complicated and quite expensive if you have a two-story roof, if you have a tile roof, if you have multiple arrays on the roof. All of these variables can complicate the remove and reinstall process, which is why there's tremendous cost benefit to replacing the roof before you install solar so that you don't have to monkey around with that for 20 or more years. If you do it right, the array and the roof can last 30 years, and if you use our mounts, that's a guaranteed winner of an investment opportunity. But obviously, when you're assessing the roof life, look at, is there any structural repair required? Waterproofing, is there any evidence of previous leaks? Are there infestations of termites or roof rats? We got those here in the Phoenix area. Isn't that wonderful? Scorpions. Unfortunately, folks, these are the kinds of real-world scenarios that folks run into. And, of course, leaks. You'll look visually for any indication that there's been water leaking up until that point, and document what kind of sheathing they have. Is it half-inch OSB or is it 3/4-inch plywood? Might you have 2-inch tongue and groove roofing as sheathing? What kind of underlayment do you have? Is it a single layer of 15-pound felt that's lapped, or do you have double 15, possibly single 30? Rafter size and spacing, number of layers of roofing. Engineering design of your racking system and layout obviously is a critical component when you're trying to develop your checklist and figuring out your proper mounting and flashing. Now, I want to point out, shingles should never be used on a low slope roof. We see that mistake being made. They must always be on roofs 212 or greater, preferably 412 or greater, because building code does allow you to use shingles between 212 and 412 pitch. But you can see here that a 412 pitch roof, as these diagrams indicate, will drain water faster than a 112 pitch roof. This is why shingle manufacturers in their instructions always say that they want the shingles installed on a 412 pitch roof. However, you can install less than 412 pitch with shingles. If you do so, you need to start using special underlayment provisions, which range from double lapped underlayment to fully adhered underlayment in some cases. You must check each shingle manufacturer's installation instructions and realize when you go below a 312 pitch with shingles, you lose the shingle warranty and the waterproofing warranty. Here's an example where we had a 112 pitch roof in New Jersey, which unfortunately installed shingles. That was a code violation, and sadly installed solar, and it leaked within the first year. So here's an example of the drywall damage from that job, and they had put a generous helping of sealant under the flashing, but that's not sufficient to stop leaking. This system would leak. The shingle roof will leak just by itself because water will creep back up a 112 pitch roof. It's too shallow and leak right in the nail holes for the shingles. Problematic. So in the case of GAF, they do specify that you have to use special underlayment and for anything between 212 and 412 pitch. They actually state in the first bullet point on their chart on the right-hand side that a roof slope of 212 to 412 is considered low, and as such requires a double layer of underlayment, and a lot of it again tends to be self-adhered underlayment. Other problems you'll run into: blistering, often caused by excessive sealant that literally will cause a chemical reaction that results in the blistering that you see. That can certainly be problematic for the life of the roof. Bruising from hail is certainly not something that a solar installer can control, but if you see it, It is important that the roof not be installed on because it doesn't have much life left, primarily because when you remove those granules, you expose the underlying asphalt to rapid deterioration from ultraviolet radiation from the sun, and those areas that have lost their granule where the hail is damaged the roof will leak in time faster than those areas that retain the granules. Curling is a sign that the asphalt has baked dry over the years and will no longer retain its waterproofing characteristics. Mold is self-evident when you see it. Common in the Pacific Northwest, Portland and Seattle have such massive mold and moss problems that if you don't tend to it, you can get a thick layer of moss that trees start to grow out of. It's kind of humorous and sad at the same time. Cracking occurs because of dysfunctional asphalt. Realize asphalt is an organic product. It is the sludge left over after you refine all of the propane, butane, heptane, hexane, and all the other distillates out of oil. What you're left with is this sludge called asphalt, and there's a lot of other various chemicals depending on what part of the earth they pulled it out of. I used to work in the oil fields in northern Michigan where we had a healthy dose of hydrogen sulfide gas in the oil, turned it green in color, emitted a poisonous hydrogen sulfide gas, which you didn't want to breathe too much or you'd die, and those contaminants, like hydrogen sulfide, remain in that asphalt, and sometimes upwards of 15% of shingles, no matter the quality, will exhibit premature cracking. You don't want to install on those roofs. Bruising due to foot traffic, common problem after solar installation. So these are some of the things that you need to be on the lookout for. You can reduce damage on the roof by using something called spaghetti matting or old carpet remnants to reduce the pressure of your feet on the roof and not tear as many granules out. Alternately, you can use special boots like these cougar paws, which have a soft foam sole that's easily replaced with a piece of felt that velcros on the bottom, which reduces the pressure of your foot in the roof so you don't bruise the roof as easily. Caution with any footwear, whether it's cougar paws with the foam sole or a pair of tennis shoes, or the worst footwear on a roof is a hard rubber sole boot. They don't have any place of being on an asphalt shingle roof, in my opinion, or many roofs. Soft-soled shoes work better for grip, and you always want to avoid pivoting so you don't tear the granules off the roof. That's the protection. Now, our first product we introduced years back was the classic comp mount, and I'll reiterate, for those of you that may have some questions building up, feel free to fire them off to me. I know I cover a lot of material in a short time, which might make it challenging for people to ask questions, but I'm going to take a sip of coffee, so if any of you have any questions, fire away, and then we'll run into the products here in just a moment. This is my first webinar back after it's about a month and a half. I was over in Malaysia for a month. It was a great vacation, but I'm going to take a little break for a sip of coffee and get right back at it. Classic comp mount is very robust, to say the least. Works with virtually all racking systems and has multiple level patented waterproofing and a simple 1-bolt installation that doesn't require that you cut the shingles. Can last for 30 years. And what makes this flashing different than most is its size. It's a full 12 inches wide, which will give you a minimum of 5.8 inches of side lap protection from the edge of your hole to the side of the flashing. You might ask, why do you need a flashing so wide? Well, in a really rainy, windy environment like Hawaii, where this product dominates, they want more side lap coverage to resist the potential for leak problems from wind-driven rain. 4 inches is the recommended standard by all the shingle manufacturers. With our classic comp mount, we go extra wide, 12-inch wide, and that gives us 5.8 inches of side lap coverage. Additionally, we make this flashing super thick to resist what's known as compression deflection. A common problem on asphalt shingle roofs, I'll show you in a minute, where the flashing the block, as you're tightening the bolt down, can depress the soft, hot asphalt on a warm day, and in a less expensive thin flashing, it can bend the edges of the flashing up. The NRCA requirements are that you use a 32 thousandths thick aluminum flashing. We've made the classic count super thick at 50 thousandths to give you more protection. Additionally, the super strong flashing can support less conventional racking systems like the tilt-up arrangements here. You don't see these often these days, but you can imagine that when you have an array tilted off your roof like that, it will capture more wind, and you need more structural capacity to manage any prospective wind loads, and the classic comp mounts strong enough to be able to configure racking systems in the manner depicted on screen. It also uses a patented multi-level waterproofing system where we fuse an aluminum flute, a cylinder, into a flat metal flashing plate under intense pressure, causing the aluminum molecules of the flute, as you can see depicted in that call out on the right hand image. The flute presses into the flashing plate, and the pressure causes the aluminum molecules to fuse between the flashing and the flute. And then the seal is positioned 0.7 inches above the surface of the flashing where the water would be, and that keeps the rubber seal away from the water. We have a secondary seal that seals the top of the flashing, and what you end up with is a very robust long-term seal that gets moved above the ravages of freezing water and ice damage that can cause problems with deck level seals, as we refer to it. Here's an example of the compression deflection I was referencing. When you make the classic comp mount extra thick, you'll see that when you tighten a thin metal flashing's L-foot down, often the asphalt underneath on a warm day, this was an 85-degree day, will depress or will displace that soft peanut butter-like consistency asphalt, and the flashing can bend up. This is a common problem that we see in the field with thin flashings, and I see Fred has a question that says, you mentioned sealant for the roof being a code violation. Well, not sealant, a sealant-only solution. If you don't use a metal flashing, you are not in compliance with the requirements of the asphalt shingle manufacturers for flashing, and unanimously they require a metal flashing. And he's asking the section, actually, Fred, I'll cover that in this afternoon's webinar, so I certainly would encourage you to join that. If not, you can always download the PDF from our website. You can read the sections of the International Building Code, International Residential Code, and the National Roofing Contractor Association's installation manuals to better understand the requirements. We include all the hardware and the sealing system, ship 12 mounts per box with all of the necessary nuts and bolts and seals. And this is just a nice side view to show how that elevated water seal raises the seal surface 0.7 inches off the roof to avoid what you see here. When you've got that seal right at the water line, sandwiched between the L-foot and the flashing, especially in ice country, when you're in a freeze zone, the water that's naturally going to be around the perimeter of your seal as it freezes will exert extra pressure on the edge of that seal, where over time causes that seal to crack and eventually leak, where raising the seal 0.7 inches above the roof and encapsulating it in a metal block protects it from the worst ravages of the environment. Here's an example of the kinds of systems that we see. If you just have sealant-only code violation, you have weak waterproofing with the seal right at the water line, but with the elevated water seal, obviously we don't run into those kinds of problems. Now we'll talk a little bit about a revision to our classic comp mount called the E-mount that we introduced several years ago in an effort to reduce cost for those areas that may not have as stringent a water protection needs as a place like Hawaii. The E-mount helps reduce material by making a slightly thinner, narrower flashing, but preserving all of the other benefits and features of our classic comp mount. The E-mount is called E-mount because the E stands for economical, easy to install, and elevated water seal. Essentially, it is the same as the classic comp mount in every way, with the exception of being 9 inches wide instead of 12, and it is 40 thousandths thick aluminum for the flashing, whereas the classic comp mount is a thicker 50 thousandths thick. However, it performs beautifully and is still thicker than the standard flashings that are often used. And the other innovation that has recently developed in the last couple of years is Folks, this is my favorite. This is our new lag screw with special seal. That seal on the left, that big chunky rubber seal, is very sophisticated in that it's a special EPDM rubber, and embedded in that big thick rubber seal is a stainless steel washer. And the whole premise is that when you insert that big thick rubber seal down into the Q block and you tighten down the lag screw, the top of the L foot now will press down on this black rubber seal. It will grow in diameter and tightly seal around the bolt and to the inside walls of that cavity, providing a robust 30-plus year life seal that's raised up off the water line by 0.7 inches. This is what differentiates this product from all others on the market, and it's by far, of any product with any roof type, we make my favorite seal configuration, the one that I have the most confidence will outlast all others, because it's protecting that rubber seal from UV, from water, from oxidation to a certain degree, because it's got limited ability to exchange oxygen. The breakdown mechanisms for rubber are oxidation, evaporation, UV degradation. And by burying it in this cavity, you're protecting it from the worst ravages. Oh, and water damage over time, both with chemicals that the water brings down onto the seal, as well as the potential damage that occurs as that water turns into ice and expands, exerting pressure on the outer diameter, which eventually leads to cracks. So this design is immune from the worst ravages of the real world out there. We do make this product available in a miniature version for demonstration purposes only. We call it our Mini Demo Classic, which now includes the lag screw and that new seal I've explained, with the rectangular block and a 6" by 6" section of flashing that you can easily use to show to a customer. Doesn't take up your whole case when you go visit them. Common problems we've seen with other flashings include flashings where the upper edge doesn't get up into the third course, as you see in the left-hand image. That means that, you know, water can run right down into the upper edge of the flashing. In some older flashings, you had to trim the shingles, which is perfectly fine, not a problem. But some of the other problems we saw were inverted boots on the old boot-style flashings. If you don't cut the shingles properly, they won't lay down and become a uplift risk in a windstorm. Some of the seals, especially in a salt air environment, give up the ghost pretty early on these cheap, thin, nitrile rubber boots, which are just not nearly as robust as EPDM, and some of them do crack. Again, in what you find is sometimes in salt air environments, you'll see premature cracking of the boots, which are, in a case of a pipe at least, exposed to full ultraviolet radiation. I showed these problems earlier with the face nailing and the water capture because of the pipe clamps and the flashing slap down on top. But with our flashings, the install process is pretty straightforward. You're going to remove one nail, maybe two, with a roofing bar, drill your hole, fill it with sealant, slide the flashing into place, install your hanger bolt or lag screw with seal, attach your L foot. It's as simple as that. This quote really says it nicely: fast installation, less labor and cost, and saves 4 hours on a project compared to conventional methods of flashing prior to the introduction of this product. To remove the nails is a fairly straightforward proposition. You're going to slide something like our roofing bar, which we do sell through our distributor network. The procedure I like is I slide that roofing bar in between the courses of shingles. It's a very stiff roofing bar, meaning it's got a slight arc to it. So when you hit that nail head with the tip of the bar, if you're very careful and press down toward the roof with your hand that's on the handle, you'll pop that nail right out, and then you can reach your roofing bar up in there and fish the nail out with the hooks on the side of the head of the roofing bar. So you'll just remove that nail, slide the flashing uphill, and as I showed earlier, make certain that the upper edge of the flashing is above the nail line, as is demonstrated by the center configuration and the right-hand configuration. The configuration on the left, as previously mentioned, is wrong. This, if you ever run into the architectural shingles, is the correct configuration, and this is wrong. Look at how much exposed side edge of that flashing you have. This was installed in the wrong course of shingles, and it gets thrown off because these sawtooth appendages on the architectural multi-layer dimensional shingles make some installers think that they only have to slide the flashing up to the bottom edge of that sawtooth appendage. Realize those are decorative only. You could cut every one of those off and they wouldn't impair the waterproofing of the roof. So to fix this, you have to install this flashing one layer of shingles closer to the roof, as I just showed in this image, and then trim out the section of sawtooth appendage because they serve no waterproofing function, and that's the way that you make this done properly. Sadly, this installer did it incorrectly and had to go back and uninstall the rail and had to pull all the flashings out and put them one layer of shingles further down on the roof or closer to the roof. So essentially, they installed mistakenly this flashing on top of the shingle that they should have installed it underneath. So now you have to move it down a layer of shingles closer to the roof. I will again reiterate that if you install the thin metal flashings with the deck level seals on a warm day, compression deflection is a problem. Fortunately, because of the robust design of our classic comp mount and our E-mount, we do not see compression deflection as a problem. But to avoid it entirely, the trick is that as you're tightening with your impact driver on your lag screw or hanger bolt, you'll rotate the block just a little bit back and forth. You don't have to do it much, a few degrees in either direction. And as soon as you keep tightening down with your impact driver, and as soon as the lag screw or hanger bolt has bottomed out, you're going to feel that you can no longer freely rotate that block. Stop torquing with your impact driver. If you continue to torque with your impact driver on a hot day, what will happen is the asphalt underneath that rectangular block will get squoze out of underneath it, and the center of the flashing will depress down into the roof. With our E-mount and classic comp mount, we see this regularly, but the flashings are thick enough that you only see the center depressed and the edges stay close to the roof. But if you have two layers of shingles, it is a risk that you could lift the edges of the flashing, which is why I encourage that you use the quick block with this pivoting technique that I just explained. As you're impact driving the screw or hanger bolt down, pivot it back and forth, and as soon as it tightens up, stop tightening down on the impact driver. No benefit to it. Now, there's a lot of sealants you could choose from. Here's a list of some common ones. I think they're all fine sealants for use with our product. Be aware that certain sealants have advantages versus others. You'll notice that some of the geocells have a lower temperature range than the ChemLink, for example, so that can be an indicator. You'll want to make sure, of course, that the sealant is compatible with the shingles, and use a 6-inch drill bit minimum to get a full depth hole. Put sealant down in the hole, and I'm a big fan, as are many of the shingle manufacturers, of adding a secondary bead, a horseshoe bead of sealant around the penetration where the flashing is to provide an additional measure of waterproofing protection. Now, sealant alone is not a reliable way to waterproof a penetration, but in combination with a flashing like this, it becomes an impressive waterproof barrier over time. You'll also want to use dabs, small dabs of sealant to glue the shingles back down if you had to pry them up just to get those nails out. Perfectly permissible method. Don't use too much sealant. You could damage the shingle. If it's a solvent-based sealant, it could end up bubbling up the shingle, and that's not something you want to see. It's called blistering, actually. But if you restrict those dabs of sealant, more frequent across the edge of the shingle, and 1/4 to 1/2 inch dabs are sufficient. We make our flashings available in mill finish, which is the least expensive, or an anodized, either clear or bronze, which is black in color. Most people that buy an anodized flashing go for the black to match shingle color. Clear anodized is something that's used somewhat in places like Hawaii, where they have white shingles and they want a clearer or a lighter colored flashing. Aluminum mill will self-anodize very quickly. It has a gray color. Some people prefer the black color or the clear color to the gray color, and that's the reason that they might choose the more expensive anodized clear or black. But if you're using it for aesthetics only, a common strategy is to use it only at the perimeter and to use inexpensive mill finish aluminum flashings on the interior where they're not visible. The Q-base comp mount, as I previously mentioned, and I see a number of questions have come in here, Paul. I'll get to those here in a few minutes when we wrap up. I'll stick around to answer any questions, but I'll kind of wrap up our last 5 minutes here explaining our other basic product, the Q-base comp mount, which I really like for re-roofs. So the Q-base comp mount is great for new roofs or re-roofs where you're working with a roofer. Here's the perfect example where the roofer put down the underlayment. The solar installer came in and put down all of the Q-bases and posts in the precise locations that they needed to be. Then he took the stack of flashings, gave them to the roofer, who installed them as the shingles went in. And this is a beautiful shot of the roof in the process where the shingles are going in. You can see the staggered pattern that shingles normally get installed on. And this is a beautiful product. So, in fact, they've got the upper edge of the flashing far up into the third course, which gives the most waterproof, robust performance. You'll notice that the actual penetration that holds the Q-base in place is positioned above the bottom edge of the second course of shingles. This is an incredibly robust configuration. The installation procedure is pretty easy. If you're dealing with just the underlayment, you can find the rafters quite easily. You'll drill your 7/32 diameter holes, secure your base to the roof, thread the post in, install the shingles around it with the flashing, and then finish with the rubber seal. You can use our mounts for installing very heavy things like water panels, water heating panels. In this example, the upper left image, you'll see that the classic comp mount was installed very close to the ridge. The installer actually had to trim up the upper half of the flashing, but they still got the flashing up under the ridge cap, which constitutes the third course of shingles. So an unorthodox configuration, but for this water heating panel, they needed to get it closer to the ridge, and this is a perfectly permissible approach. In fact, you'll notice that in this configuration, the classic comp mount flashings were installed very far up into the third course. They actually cut the block up into the second course to get more waterproofing performance. I think this may have been, I'm not sure if this was in California. It looks like a California roof. It's possible that this might be the kind of more conservative waterproofing approach that you might find in a place like Hawaii. This is an example, of course, of our Q-base comp mount. You'll notice that we've cut a 1/2 inch of shingle around the base of the cone to make certain that we have ample room between the bottom edge of the shingle, the edge of the shingle, and the cone to facilitate efficient water drainage and drying out. You don't want that shingle to come right up to the edge of the cone because that will capture water. By trimming a 1/2 inch space, or here this might be a bit more than a 1/2 inch, maybe 5/8 inch, you'll dry it out more quickly and get longer life out of the roof system. You can also see that you can have more unconventional configurations such as the tilt-up array on the water heating panels. We've gotten our products approved with a variety of racking manufacturers such as Unirac and Pro Solar and Iron Ridge and others. And we've got letters of approval from the major roofing manufacturers, including GAF, Owens Corning, IKO, CertainTeed, Pabco, so on and so forth, Malarkey. And we do publish on our website all of the relevant structural load capacities, such as your pull-out capacity here in Doug fir lumber, 2,500 pounds average pull-out capacity versus cedar where you get 1,350 pounds. Or we also show the shear capacity, the side load capacity, still a robust 2,200 pounds in Doug fir lumber. We do have conduit mount flashings, which are helpful when you're trying to take that conduit run down into the attic, and this would give you a code-compliant way of doing it with a clever seal that will work for 1/2, 3/4, or 1 inch conduit. It's a stair-step seal that you just cut with a utility knife, and the installation procedure is shown on our website as well as in the installation instructions in the box. You'll notice that we are cutting that pyramid-shaped seal in the upper right-hand image here to fit a 3/4 inch conduit. If you cut that last stair step out, you would be able to accommodate a 1-inch conduit and bring that power down into the attic. We also manufacture conduit mounts, and many people have for years been gluing a piece of plasticized lumber to the roof to raise a conduit off the roof, but that's not a code compliant approach. Using a proper flashing with a elevating block like our conduit mount shown here is the code compliant way to raise that conduit off the roof. Some installers like to raise it even further off the roof, and you can do that with our standard mounts using a post that we sell as an accessory product along with our roofing bars and hanger bolts that would be able to be longer to accommodate those roofs that aren't as common, that have insulation between the sheathing and the rafters. The post here can elevate the array off the roof for more thermal venting of the array. There's a variety of reasons people like to use posts. But our quality speaks for itself, with stronger engineering, longer spans, and fewer penetrations, in the end equaling lower cost. So I appreciate everybody's participation. I do want to reiterate that we have roof attachments for virtually every roof type, with the exception of standing seam metal panels or corrugated metal panels. Our E-mount product can be gotten as a sample by clicking the green free sample button on the website. Check that out. I'm a big fan of this product. Our replacement tile mounts or tile replacement mounts have been available for a few months and have caught on very well. The beauty of this product is you remove the tile, you save that to do repairs on any broken tiles during the install, and you now have a flashing that form fits in with the S-tile, W-tile, or flat tile, concrete tile roofs. We have conduit penetration flashings and conduit mounts for tile roofs, and our quick rack rail free system for asphalt shingle roofs, which does not use rails. It helps speed up the installation process by having a relatively modest amount of hardware to mount your modules to the roof in a way that ends up with a very attractive looking array. Check out our website for more information on our training. If you want to get in touch with me, my email address is shown on screen. That's Jeff, Jeff. My last name is pronounced Spies, but it is spelled Spies, S-P-I-E-S, at quickmountpv.com. And you can also check our website for frequently asked questions, as well as product information, engineering documentation, training downloads, a list of trade shows and events and distributors, and don't forget to get your free sample of any product you desire to better evaluate it. Here's a list of all the events that we'll be at this year. We've already conducted a few. This week, as we speak, in fact, as I speak, the Oregon Solar Expo in Portland's going on. Shout out to all my friends up in Oregon. I will be up there next year to debut or to show you all the documentary on the pioneers of the photovoltaic industry. My personal favorite event's coming up next month, the Midwest Renewable Energy Fair in Custer, Wisconsin, where we will have our new rolling solar training van. I will insert a picture in future trainings, but we do have that now available. And Intersolar, which is a major event for Quick Mount PV, is in July in San Francisco. Finally, Solar Power International, one of the biggest events in the industry, in Las Vegas in September. Check our website for monthly webinars. You can download video tutorials, get copies of this presentation in a PDF format, view previously recorded webinars, and register for hands-on training opportunities. For those that have listened the whole time, you're going to get 1 credit emailed to you in 1 to 2 weeks, not tomorrow, unfortunately, 1 to 2 weeks, and you'll have all the links to download this presentation, whether it be by PDF or view the recorded presentation from today. We do appreciate all the feedback, and I am going to take questions, the first being from Paul, who asks, is there a torque value? No, absolutely not. The problem with asphalt shingle roofs is because of this problem with the asphalt being pliable in warmer temperatures, you cannot use a torque value to assess the proper tightness of the lag screw or hanger bolt when you're securing your roof attachment. You must go by feel. And as I said, if on the Q-base comp mount, on the Q block, the classic comp mount, the E mount, anything that uses our rectangular block, pivoting it back and forth is the real way that you assess the torque, if you will. Torque's the invalid. You're looking at fit up. And if you don't feel that block rotating anymore, it means you've taken up all the clearance between the threads that are engaging the rafter and the L-foot that you've now snugged up to the top of the block, and the block is all the way down on top of the flashing's all the way down on the shingles. There's no additional clearance. If you continue to tighten that block, or the bolt, after you've snugged that block up and it no longer can rotate freely, you're just going to displace the asphalt, or worse, you're going to start to strip out your lag screw. You don't want to do that. Rob asks, is there any method to seal the location where the lag bolt penetrates through the shingle sheeting underneath the flashing? Well, that's what the flashing is doing, is performing that sealing of that penetration, Rob. But certainly, as I showed in that image, you would add that additional bead of sealant in a horseshoe, upside down horseshoe around the penetration to provide additional water sealing performance to this flashed penetration. Obviously, you put sealant down in the hole, so that combination of sealant down in the hole, as the lag screw goes down in that hole, it's filled full of that sealant. The sealant will flow up out of the hole, seal off the penetration. You'll have that horseshoe bead of sealant on the underside of the flashing that provides an additional barrier to water, and the flashing itself, of course, diverts the vast majority of the water. Paul says, got it, thanks. Fred asks the depth of the lag into the rafter. We've engineered our hardware, Fred, so that even with 2 layers of shingles, you'll be fine. But if you do have insulation, typically speaking, what we do is we publish load capacities per inch of engagement into the rafter. So if you don't have as much engagement in the rafter as the typical configuration would permit, you can go to our specifications, calculate that, provide that to your building official to validate how much securement you have to the roof. I prefer to see a minimum of 2 inches of engagement on every lag screw into the roof. Fred goes on to say, I have a roof that has a layer of asphalt shingles covered with a cushion, then rubber roof. Is it legal to install a solar system on it? Probably not, Fred. I think you might have to re-roof on that one. Roger asks, can I join the webinar schedule for this afternoon? Absolutely. Go to our website, locate it in our list of webinars, and register it. You should be fine. Siddharth says, thank you, Jeff, and thank you, QMPV team, and that's the last comment/question. Thanks, everybody, for participating today. I hope some of you will participate for our Roofing Codes and Standards webinar this afternoon, I think at 1 o'clock. Check the website to double-check that time. And I've got a couple webinars tomorrow, but it's been great being here with everybody. And let me just see if there's any other comments or questions. Nope, that's it. Thanks again. Have a great day, and I'll hope to see you all at a future event or a future webinar. Adios.